Okay, Unit 2. Unit 2 is all about differentiation, how to do it, a little bit of why we do it, but mostly the mechanics of how we do it. And so I'm going to introduce us to two rules we're familiar with from our work last year. One is the power rule, how to take the derivative of a polynomial. The other is the product rule, how to take the derivative of two functions multiplied together. That's the idea. So in this lesson, some basic theorems that help us in differentiating. Big theorems. First things first, the derivative of a number is 0. The derivative of a number is 0. We can prove that. It's not terribly difficult. The derivative, by definition, is f of x plus h minus f of x over h, limit as x approaches 0. If the function is a number, then f of x is a number. But f of x plus h is also a number. You take the limit as h approaches 0. Yep, that makes sense. It also makes sense from a graphical standpoint, because we know that the derivative of a horizontal line is the slope of that horizontal line. That's 0. So it makes sense to us that the derivative of a number is 0. Theorem 2. The derivative of a sum is the derivative of the first plus the derivative of the second. And just so we're clear, folks at home, this notation means the derivative with respect to x. It is the derivative with respect to x. So if we take the derivative with respect to x of the sum of two functions u and v, we expect to get the derivative of u plus the derivative of v. This also is an easy proof to sketch. Limit as h approaches 0 of f of x plus h minus f of x over h. Again, we take the thing at x plus h minus the thing at x and divide by h. Well, it's not hard to reorganize the terms here. Not hard at all to reorganize those terms. And you can pretty easily see that this thing is the derivative of u, and this thing is the derivative of v. So we're okay there. Thing 3. And again, we've got to build up to the to the power rule here. The derivative with respect to x of some number times some function is the number times the derivative of the function. In other words, constants just come along for the ride when they're multiplied in front. Well, why does that make sense? We're going to take a limit as h approaches 0 of c f of x plus h minus c f of x over h. Limit as h approaches 0. Well, c can be factored right out of there. And oh look, this thing is the derivative of f. So far we know that the derivative of a number is 0, the derivative of a sum is the sum of the derivatives, and the derivative of a constant times a function is the constant times the derivative of the function. So really, all we need to get polynomials is to be able to show that the derivative of x to the n is nx to the n minus 1. Because if we can do that, we've got polynomials. We've got all polynomials, because all polynomials are sums of x to a power times a number. Add it all together. If we can do this, then the power rule works. So I want the limit as h approaches 0 of f of x plus h minus f of x over h. Limit as h approaches 0. So here's the crazy thing about that. We write the numerator in a very creative way. We take advantage of the fact that, here, I got to go to Scrapland for this. I'm going to take advantage of the fact that, if you have a to the n minus b to the n, you can actually write that as a minus b times a giant long product. A to the, that's a minus 1. A to the n minus 1 plus a to the n minus 2b plus a to the n minus 3b squared, and so on until you end up with b to the n minus 1. This is actually a factoring. You can check yourself with FOIL, make sure it works. So what does that mean for us? That means for us that this numerator can be written as h times x plus h to the n minus 1 plus x plus h to the n minus 2 times x plus all the way down plus x to the n minus 1. All over h. And so this drops out. And so what ends up happening? What ends up happening is you get x plus h to the n minus 1 plus x plus h to the n minus 2 times x plus all the way down plus x to the n minus 1. Well, here's the question. As h gets closer and closer to 0, this is x to the n minus 1, this is x to the n minus 1, this is x to the n minus 1. They're all x to the n minus 1 if h gets closer and closer to 0. How many are there? There are n of them. And so you get n times x to the n minus 1. Now, you do not have to prove things like this. That's not part of our course. But you do have to know two things. One, you have to know that it comes from somewhere, that the definition of derivative works. The other thing you have to know is how that applies to polynomials, because what this means now is that if I ask you to differentiate a polynomial, 6x to the 4th minus 12x cubed plus x to the negative 1 plus 4x to the negative 2, you can play that game. You can say y prime, which is just a notation for the derivative. You may also write dy dx. That's how that's read, dy dx. You just say to yourself, this power comes down in front, multiplies by the 6, and the power decreases by 1. This power comes down in front, multiplies by the negative 12, and the power decreases by 1. This power comes down in front, power decreases by 1. This power comes down in front, multiplies by the 4, power decreases by 1. And we could do a billion examples, but you're well familiar with this from our work from last year. The other thing we should talk about before I run out of time is the product rule. It's so much fun. The product rule says if I have the derivative with respect to x of the product function u times v, that's the same as u dv dx plus v du dx. And so we all sing together, the product rule is so much fun. It's 1 prime 2 plus 2 prime 1. Oh, calculus, oh, calculus. How tough are both your branches? Going to take a limit as h approaches 0 of, oh, I'll bring that guy in, won't need him yet, f of x plus h minus f of x over h. That's by definition, limit h approaches 0, function at x plus h minus function at x divided by h. So, for reasons that will become clear soon, I'm going to break this sucker up. I'm going to add and subtract the same thing. I'm going to subtract u of x plus h v of x and add u of x plus h v of x. That does not change anything. Now I'm going to divide by h, but I'm going to divide by h in 2 pieces. I'm going to divide by h, that's the whole thing divided by h, but I broke it up so I could deal with things. So what does that mean? On the left, here, what factors out of the top? U of x plus h. And what's left is v of x plus h minus v of x over h. On the right side, what factors out of there? Well, v of x factors out of there. So I'll just let it factor out. And what's left is u of x plus h minus u of x over h. So what do I know? I know as h approaches 0, this gets closer and closer to u of x. This, as h gets closer and closer to 0, that's the derivative of v. That is the derivative of v. Plus, this is unaffected by h getting closer and closer to 0. And this, as h gets closer and closer to 0, is the derivative of u. And you get the product rule. The product rule is so much fun. It's 1 prime 2 plus 2 prime 1. And so those are things that we remember from our time last year that we have to bring back to the front of our minds. Product rule has to be available. Power rule has to be available. We will look in class time at how that shakes down, but I wanted you to be aware that those things exist, they are real, they are true, and more importantly, they play off of the definition. So that's enough preparation. First 15 minutes of our class time will be practice time with that, and then you guys will get to work, and you have been amazing. Okay. Thanks, everybody.